All right, great trig problem here in number 75. The first time we introduced this, we definitely want to make sure we get all the steps down. They do a good job of giving us solid directions. If cosine of theta is 3 over 5, we're going to do some solving with problems like this. So the first step to solving that is, can you draw a right triangle and place values on the sides so that the cosine is 3/5? So any right triangle works. We need to define a theta. And then if the cosine is 3/5, we can say the adjacent side is 3 and the hypotenuse is 5. That gives me the cosine ratio of 3/5. Now in the unit circle in B, use your unit circle and talk about where would two possible locations for theta be. Well, if cosine is positive, that means it's got to be in the first quadrant or the fourth quadrant. And I mean, it could be here basically, or here. We'll get a little closer to maybe its exact value in a second here. Use the Pythagorean identity or right triangle to solve for all possible values of sine. So I think the right triangle part of that is just, it's a 3, 4, 5 triangle. We should recognize that. It's going to be a little higher up than it is out, which I guess is good that I put it about where this is. All possible values of sine. So sine is opposite over hypotenuse. So either sine is 4/5 if it's in the first quadrant, or negative 4/5 if it's in that fourth quadrant. It's either positive or negative. And then all possible values for tan. And that should be pretty easy too. Tan is opposite over adjacent, so tan either equals 4/3 if it's in the first quadrant, or negative 4/3 if it's in the fifth. So the biggest takeaway I could say is, when you're given the ratios of a side, cosine theta equals 3/5, the first thing you want to do is draw that right triangle and see what pieces you can come up with from there.